Hey guys, this is Dan, and today we're going to be talking about basic statistics in Excel. To get started, we're going to explain the dataset that we're going to be working with. Now, there's a bunch of grades here, and there's a bunch of universities on the other end. And what we're going to be looking at is the diagnostic exam we apply to our students getting into our Excel school, our classroom Excel courses, and figuring out which universities produce the best prepared students in Excel. Now, the exam is not easy, and a lot of students actually fail the exam. So, let's get started. You'll notice here that we have all the universities that participated and how many students are coming from each university. And notice that there's like 3 universities that take up the lion's share of all of the students. We have a grand total of 784 students here, and almost half is taken up by the University of Guadalajara. Now, if you're not familiar with the city of Guadalajara in the state of Jalisco in the country of Mexico, all of these universities are going to look like alphabet soup institutions like for you, all right? So don't despair, you don't need to actually know any of them. Now, the rest of the students are coming from other universities or ITESO or the rest, all right? So we have here what is called like an exponential distribution, where just a few universities take up most of the students that are coming out and studying Excel on their own. All right, guys, so that's it for the analysis of universities. And now let's take another look at the dataset from another perspective. How about the grades, all right? How are the grades distributed? Well, notice here that I have the grades clustered by, well, how many students actually got a particular grade. In this particular scenario, in this particular instance, we notice how the grades tend to cluster at the left end of this graph, of this chart. So that means that most students actually, not only don't they pass, I mean, passing grade is here with 60, they barely know any Excel, all right? They barely know any Excel. They're all clustering. They're all clustering right here at this end of the chart. So that means, say, for example, that most of the students would have grades like 12%, 14%, 24%, and the one that has the most, 36%, all right? Whereas very few students are actually on this side of the chart. So this is what we call a normal distribution. Now, that's a little bit more advanced statistics, but I think that these two charts here will give you a pretty good overview of the dataset that we're going to be working with right now, all right? We're going to be working with a dataset that is lopsided on the end of the universities. I mean, we have most people coming from the University of Guadalajara, and most people are terrible at Excel, all right? Most people are terrible at Excel. So let's get started. The first thing that we're going to be talking about is the central tendency measures, all right? Now, this is a throwback to your elementary school days. They probably didn't throw around big words like central tendency measures in elementary, but they did make you calculate the mean and the median and the mode, and that's it, all right? That was pretty much everything you saw about statistics during elementary and middle school. So let's talk about these basic items. Now, the mean, as it says right here in the definition, it's the sum of all values divided by the total of the values. But I think that the most important part is right here. It's understood as the center of gravity. So, if I were to take the mean of all the grades, basically what I would be doing is imagine that this little chart over here is a seesaw. And I am trying to balance aforementioned seesaw. So, well, I can't. Excel is not going to let me rotate this thing. Anyway, as I was saying, imagine this is a seesaw and I'm trying to balance the seesaw. So where would I place the central post of the seesaw to make sure that it stays perfectly balanced? Now, that question is what we're trying to answer with the mean. So what we're going to do here is calculate the mean using this formula called average, all right? Now, the beautiful thing about Excel is that you don't need to know any mathematical procedures about statistics at all. Excel already does the calculations for you. All you need to know is how to interpret what it is that you're looking at. So let's go back here and calculate the mean of all of the grades, all right? Let's calculate the mean of all of the grades. Now, the mean is pretty much 38.99%, which for all practical purposes is 39%. So that would mean that if I were to come over here and I wanted to insert the base of my seesaw, imagine this is the base of a seesaw, I'd go right here at 38.99%. And this, if I were to perch my chart atop this little triangle, it would be balanced perfectly, all right? It would be balanced perfectly. Notice how it's skewed towards the left, which means a lot of people are terrible at using Excel, all right? A lot of people are terrible at using Excel. There's a good reason they're taking the actual classroom Excel course. All right. So that is the mean. Now let's talk about the median, guys. Let's talk about the median. The median is the value of the data that takes the central position when the data are ordered according to their size. So that means right now the data are according from smallest to largest. If I were to count up everything, in this case we have 574 students that actually finished the exam. Oh, notice the difference between this table and this table. In this table, we have a bunch of students that didn't finish the exam, all right? A ton of them. Whereas here we have a bunch of students that just the students that actually finished the exam. Well, whatever. The point here that I'm trying to make is that if we were to take, say, for example, the 574 students and go all the way to the middle, 574 divided by 2 is 287. So I'm going to go over to 287. Where are we? Just bear with me. All right, guys. So if I go over to the very middle, I'll notice that my middle grade is 36%. Now, luckily, I don't have to do this by hand every time I want to calculate the median. I just go in here, and Excel has a trusty formula called median. You guessed it, all right? They're not big on creativity up there at Microsoft, so don't expect any fancy names for the formulas. So median is called, just apply the median to all of the data that you have. And notice that we get 36%, all right? So the guy at the very middle is right here in 36%. Things that you have to look out for when you're analyzing data sets for real. To make sure that the mode and the median make sense, make sure that they're clustered together. That would mean that you would have a normal distribution like this, all right? You would have a normal distribution like this, and basic statistics apply. Now, if the median and the mode are very far apart, that means that you need some higher end level analysis, because you'd probably have something, a distribution more like this, an exponential distribution. Those behave differently. But let's not concern ourselves with that right now. Let's just go back to central tendency measures. Now we have the mode. The mode is the value that repeats itself the most. The mode is the value that repeats itself the most. So I'm going to figure out what the mode is by typing in mode right here. And notice how I get three different possibilities. And the one that I wanted, mode, actually has this little warning sign right here. All right, actually has this little warning sign out here. And it's pretty much telling me that this function is available for compatibility with Excel 2007 and earlier. So if you were to go back to prehistoric times when cavemen were actually using Excel, which was the age of Excel 2003 and earlier, we'd have this one available, and it would be cool. But it's not cool anymore. We have mode multi and mode single, which are two very different formulas. And we'd probably be left wondering, and which one is the one that I want? I just want a simple mode. All right. To avoid any confusion, mode single, I mean, if you're just taking simple notes, mode single, that's the one that you want. That's the one that reflects its, that's most like what you were taught in elementary school. Mode multi, as the explanation says here, it returns a vertical array of the most frequently occurring values in an array or range of data, all right? So this is for higher level statistics. You don't need to concern yourself with that right now. It's just mode single on the distribution of grades. And you'll notice that once more, the grade that repeats itself the most is 36%. We can verify that. We can verify that by coming over to our graph or chart right here and noticing that the bar for 36% is the highest. All right, noticing that the chart for 36% is the highest. And notice how they all tend to cluster together. That's why they're called central tendency measures, because we are trying to figure out where everything is, tending to, all right, where everything is tending to, and the center of pretty much everything is right here, about 30-something%, which tells me that most people know what little Excel they learned in school and what little Excel they learned by just, here's your computer, here's your workspace, figure it out for yourself. All right, guys? So let's come over here and finish up with the demi-range. The demi-range is the number that is exactly between the largest and the smallest number. All right? Now, if I were to try and figure it out by, say, Excel formulas, I wouldn't be able to. All right? I wouldn't be able to. But the mathematical formula is pretty simple. I have to take the largest number minus the smallest number, get 92%, and then divide that by 2. All right? And the demi-range tells me exactly that we have 46% range from one end of the distribution to the other. All right? What does this mean? The lowest possible grade is 0. The highest possible grade is 100, but the highest grade that anybody actually attained was 92. So between the lowest grade and the highest grade, if you were to position yourself exactly in the middle, you'd have a range of 46 points between the two. All right? That's what the demi-range measures. Now, or the semi-range, well, however you want to call it. Now, that is not, I mean, we covered that because it's in the textbook, but guys, it's absolutely not something that you usually use in your central tendency measures. It doesn't really give you as much information as the mean, median, or mode. All right? Now, I think we're good on that. I think we are good in the central tendency measures, and we've done enough of our elementary school throwback. Now, let's go over to something that a lot of people actually don't know, which is distribution. All right? Now, the distribution measures, this is something that's really interesting because it really livens up our data set. All right? Central tendency only tells us that people are clustered right here at the middle is somewhere around 36%, 38%. All right, guys? But the distribution measures tell us how far away the apples tend to fall from the tree. All right? So high distribution series, high distribution data sets would imply that this little bell here would be very distributed very far out to the ends, all right? Whereas low distribution measures would imply that everything is actually very clustered right here in the middle, all right? So distribution measures. The first one that we have as distribution measure, and the easiest one, is the difference between the largest and the smallest value. We already knew that from the beginning. I mean, the difference from the smallest and largest value is 92 minus 0. All right, guys, 92 minus 0, and well, pretty much we're distributed throughout a range 92%. All right, the difference from the smallest value, which is 0, some people actually got a flat out 0 on the exam, to the largest value, it's 92%. All right, guys. Now, the deviation with respect to the mean. The deviation with respect to the mean, this is something interesting. It's the difference between any value and the mean, all right? It's the difference between any value and the mean. Now, the deviation with respect to a mean, it's not calculated. It's not calculated for the entire data set. It's just pretty much, say, for example, I don't know, and it's going to sound pretty stupid, but say, for example, we grab 48. So the deviation of the guys that got 48 with respect to the mean, would be 48% minus the mean right here, and that is the deviation with respect to the mean. Now, this seems pretty inconsequential, and it probably is. Almost nobody ever uses it unless we're talking about a single data point instead of the whole data set. But in here we have variance, and let me change the name, it's in Spanish, variance. And it's the mean of deviations to the mean. So basically, what I would have gone about doing right here is, say, for example, if we were talking about doing this by hand, I would figure out the deviation with respect to the mean of each and every single data point, okay? Deviation to the mean of each and every single data point. So it would be, say, for example, this one minus the mean. All right, guys? And there we go. We have to deviate the deviation with respect to the mean of each and every single data point, and how far away are they from the mean. Now, once we do that, then to calculate the variance is pretty much the mean of the deviations to the mean, which means that I'm going to calculate the average of all of these deviations. All right, I'm going to calculate the average of all of these deviations, and you'll notice that I get 0%. Why? Because the deviations from one end tend to cancel out the deviations from the other end. So that's why we are going to have to use absolute value. All right, that's why we're going to have to use absolute value to make sure that the negatives don't cancel out the positives. And now we get an average of 15.34%. Now that is the variance. How would I go about calculating the variance without actually going through all of the motions of doing the table and all the mathematical proceedings? Quite simple. Excel has its own formula for variance. All right. Now it's not called variance per se. It's called var. All right. It's called var. And it tells me here that calculates the variance based on the entire population. Well, that's var.p. Do you notice how it says var.p? P stands for population, whereas var.s estimates the variance based on a sample. Now, these are basic statistical terms, all right? Population and sample. Population and sample. What's the difference? Population is pretty much when you have the aggregate of everyone who participated, okay? Everyone who participated, or everyone that's in the universe. Let's call it like that. Everyone in the universe. Whereas the sample would be you grab just a small bunch of people that participated or that were in the universe, all right? And you measure them and then say, all right, from this little small group of people, I can infer that the population behaves like this, all right? So sample just a small bunch of people from the universe. All right, so say for example we're holding elections. We want to figure out the electoral preference of everyone in the country. That's an analysis that takes place at the population level, because we're literally giving everyone the opportunity to express their opinion about who should be president, all right? Who should be elected president. Now, that is an analysis at the population level. And an analysis at the sample level, say we're holding elections and we have a newspaper, we want to make a prediction about who would win. So we just call up 300 people. Preferentially, they should be random people, not just Fox News viewers or MSNBC viewers, but random people. And then out of there, we should be able to infer how the population is going to act. All right. So that's the difference between sample and population. Going back here, then which one should we use? Which one should we use? Well, that's up to you to define the methodological, the methodological validity of this. Now, there are entire theses and subjects and everything written at the PhD level about it. But in this particular instance, we're going to go and assume that the entire population that I have here is the entire population, the entire universe, all right? It's not a sample, it's a population. And I'm going to get the variance of the data. Now, why does Excel ask you for the difference? Because the difference is, the formula, the mathematical formula is a little bit different for variance, all right? It's a little bit different. All right, we get a variance of 3.58%. Now, the standard deviation is the square root of the variance. Now, again, I don't need to calculate it. It's just stdev for the population, which is going to be right here. And again, standard deviation is 18.91%, all right, 18.91%. Now, standard deviation is pretty much the thing that you use. Standard deviation is the one that you're going to be using up the most, all right? So what that means is we have our mean right here. And it's the center of gravity. Now, standard deviation, I'm going to start doing some squiggly lines right here. All right, so the mean would be right here, and it's our center of gravity. Let's make it all thick and large and another color to make sure that you understand that. And we want to figure out the standard deviation is going to be 18%. Standard deviation is going to tell us where most of the values are clustered in, all right? So most of the population is going to be plus or minus, within a grade of plus or minus 18% of the actual mean, all right? So that would mean that I would have, say, for example, what was the mean again? 39%? All right, so I would have 0.39 plus standard deviation and 0.39 minus the standard deviation. Most of the population, like about 60% of the population, is within these two limits, all right? So on average, people get 39% in our Excel exam, and they mostly cluster, most of them are clustered between 20 and 57. So not a passing grade. People really, really don't know Excel. And of course, the rest, I mean like 40% of the population are outside those boundaries, all right? Outside those boundaries. It's a little less than 40% actually, but they're outside those boundaries. They're either in the camp that knows absolutely nothing about Excel, or they're either in the camp that, well, actually sort of knows Excel, all right? But notice how the tail is longer on this end, which means that even if you are outside the 57% threshold, it's still a long ways to go to actually getting to the elite Excel users club, okay? So that's pretty much it for distribution measures, all right, guys? That's pretty much it for distribution measures. You probably do not need to concern yourself with this at all, all right? The only one that you're probably going to be using throughout the rest of your life is standard deviation, and you don't need to know how to calculate it. You just need to know the proper Excel formula for it. All right, guys, so that's it for the distribution. Now, frequency distribution, and this is something that I fight a lot with my students about, all right? This is something that I fight a lot with my students about. It's the weighted frequencies distribution, all right? It's the weighted frequencies distribution and the weighted averages and standard deviations. All right, guys. So we have here a table of 451 students, all right? We have a table here of 451 students that took the exam. If you remember, we had something like 700 in total, but here I'm just grabbing the most important universities in the city, all right? The most important universities in the city, and well, those pretty much just sent the most. Now, you get the numbers here, you confirm that most people are actually coming from the University of Guadalajara. It's probably a little less, no, it's actually more than half. More than half of the people are coming from the University of Guadalajara. And the grade that they got, well, here are the standard grades. The University of Guadalajara, supposedly, they give out 2 semesters of Excel. And for all the good it does them, they're just a tiny little bit above the average, all right? They're just a tiny little bit above the average that we had for the whole of the population. But what if we wanted to calculate the average of just these few universities? All right, guys, of just these few universities. Well, this is where a lot of my students actually stumble and trip and they fail, all right? Because most people that are unaware of math, or that they just can't, for the life of themselves, they can't remember 7th grade math, they go about and do this. Equals average, and I'm going to average all of these grades, and there we go. The average for all of these 9 universities is 39.82%. I'm done. I'm a statistical genius, and let's move on. All right, well, wrong. Like, terribly, absolutely, invariably wrong. These grades, they're not all made equal, all right? The grades, the average grade for the University of Guadalajara is worth far more than the average grade for SETI. Why? Because the University of Guadalajara sent 263 people, whereas SETI has only sent miserable 13 people. Of course, these guys are going to be worth more, and we have to take that into consideration. We have to weight that, all right? We have to weigh that. All right, guys, so how would I go about weighting that? Well, it's actually pretty simple, but there's no formula in Excel to do that. There's 2 ways around it. You can actually do the math, or you can do pivot tables. I'm going to show you both. Doing the math is simple. I need to add an extra column that actually calculates the weight. So weight of uni, let's call it that way. All right. So I need to figure out what percentage each university represents of the entire universe that I'm calculating. So I have a grand total. I have a grand total here of 451 people. All right, 451 people, and I'm trying to figure out, say, for example, the University of Guadalajara, what percentage of the total it represents. So it's just a simple manner of going out here and dividing 263 divided by 451. Now, sounds simple, but you'd be surprised about how many of my classroom students can't do that simple operation even after they finish their bachelor's, all right, their university. So that probably tells you that most of these universities are crap. All right. So the University of Guadalajara is responsible for more than 58% of people sent out here. And Let me just do an absolute reference on this little red one. So I can drag this down, and there we go. All right, guys, the sum of all of this, they should be 100%. That's it. And you'll notice how each university is weighted. Notice how the public university is worth far more than the rest of the private ones. All right, guys. So that is the weight of the university. Now, once I've calculated the weight, now I need to do a new column called weighted grade, in which I will multiply the weight of the university times the actual grade. And there we go. Now, this is much more amenable to me calculating the weighted average. So the weighted average is now in this instance going to be 40.078%. And I'd probably be right, all right? I mean, that's close enough for comfort. I'm supposed to be right. But there's another way to go about calculating that. And that is using pivot tables. Now, notice I already have the pivot table here set up. And this is not the place to learn about pivot tables. I have a video, I have a webinar, I have an online course to learn about pivot tables. So there's a bunch of resources for you to learn about pivot tables. Right now, I just want you to check this out, okay? I have the pivot table here with just the universities. I'm going to bring down here the grade down here to values. I'm going to click value field settings and change it into average. And notice how I get the exact same average grades right here. I get the exact same average grades. Say, for example, University of Guadalajara, 41.8%, 41.8%. ITESO, 43.63%, whereas 43.636%, all right? So I have the exact same grades. Now, let's check out how many people come from each university from the pivot table. I grab grade, drag it down here to values, and change it to, well, count is fine, just not in percentage. Let me change it to number. There we go. So we have the exact same amount of people coming from the university. So what I'm about to tell you is going to seem a little confusing at first. When you use the pivot table to calculate the weighted average, and you just tell it, grab the grade, calculate the average, then this little number here is going to be the weighted average, all right? This little number here is going to be the weighted average. And we can assume it's absolutely correct. But then again, we have a little question. Why is this number not equal to this number? If what we did by hand was supposed to be correct, then why are we not getting the actual average? I mean, who is correct? Either by hand or by pivot table? Well, actually it's a pivot table. But the pivot table is the reason why why the one by hand is not as correct as the pivot table. Why? Notice how we have the exact same amounts. Notice how we have the exact same amounts both by grades and by count of grades. I'm sorry, by the amount of people that come from each university. But let's go look at the original table. We have a bunch of people right here that didn't finish the exam. All right, we have a bunch of people right here that didn't finish the exam. So what that means is that those guys, they're getting counted here. They're getting counted, but they're not being included in the average. All right, they're not being included in the average, and that is the reason for the difference. So when we're being asked for the mean, you can point to this one. All right, you can point to this one in the pivot table. Excel knows what is best. Excel knows what is best when it comes to pivot table. Now, finally, the standard deviation. Well, that's pretty simple. I'll just go over here, and instead of average, I'll go over here to value field settings. And you guessed it, there's a way to calculate the standard deviation. All right, let's do it for the whole population. There we go. Standard deviation is going to be 18.736%. All right, and oh, I lost my mean because I lost my average. So again, let's change it up to average. It's going to be 40.384%. All right, 40.384%. All right, guys. So, well, that's it. We have the mean and we have the standard deviation. Standard deviation should be percentage based. There we go. All right, guys. Now, position, all right? Position. This is the last and probably the least, But we have to figure out the position measures, which means pretty much where each quartile or where each decile falls when it comes to grades. Now, let's go back to this little chart. Let's go back to this little chart right here. All right, when we're talking about quartiles, we're trying to figure out where 1/4 of the population is grouped, all right? Where 1/4 of the population is grouped. Right now, we divided the population in half. And that half is separated pretty much by the average. But it's one way to separate it in half. Let's check out the way to separate it, other way to separate it in half. So, what we're going to do here is just use the quartile, all right? The quartile function, return the quartile function. Now, what we need is two things, the percentages and the values. The percentages are going to be, say, for example, just let me check what quartile wants. And it's going to be the array and the quartile, all right? Now, notice how the quartile here is asking for 0, 1, 2, 3, and 4, all right? So what that means is that we have to figure out that we want the first, second, third, and fourth quartile. And the value is actually going to be quartile inclusive. Let's use quartile inclusive. I'll explain that in a little bit. Let's go over here to grades. Let's go over here, or well, to normal distribution, and do the quartile exercise. Oh, I forgot to. Okay. Go here again. Normal distribution. There we go. Comma, and let's choose the first value, number 1, in order to bring out the first quartile. So that means that we get a 24%. What does it mean? Well, you go back to normal distribution and you draw a line. Again, I'm going to use my masterful Picasso paintings right here at 24% inclusive. That means that one quarter of the population is below the 24% mark or includes the 24% grade. All right. So why? Because I used notice the thing right here, quartile.inc. All right. So inc means inclusive, and it means that it includes whatever it's telling me. All right. It includes this 24%. So that means that, I mean, it's sheer coincidence, but 25% of the population is at or below a 24% grade. Now, they're usually not this close together. I mean, it's just a coincidence that it's a difference of just 1%. But that means that we can safely say that 1/4 of the people that took the exam is at or below 24% grade. All right? Now, let's check out the second quartile. Now, for the second quartile, I'm just going to drag it down because thanks to my reference, I know it's here. Now, the second quartile is not the same as the mean. It's the same as the median, all right? It's the same as the median. So that means that, let me grab this one, change it right down here to 36%. You have 50% of the population is at or below a grade of 36. Now, more interestingly, the second quarter of the population, is between, it's higher than 24 or up to and including 36% in grade. All right, it's up to and including 36% in grade. All right, now let's check out the third quartile. Where is it? Here we go. Third quartile, we're going to grab it, drag a little down here, and the third quartile, that means 75% of the population is at or below 52% grade. All right. So if these items were perfectly distributed, you'd expect 3/4 of the population to be at or below 75%, but that's not the case. All right, that's not the case. It's actually that they are at or below 52, a grade of 52. All right, and the third highest quartile, or the third highest 25%, they live somewhere in between 36 and 52. All right, guys. So finally, the fourth highest range of population is at or below 92%. Why not 100? Because nobody actually got 100. All right, the highest grade ever has been 92 in that exam. All right, guys, so now let's talk about percentages. Let's talk about deciles. They behave pretty much the same as quartiles, but in deciles, we're dividing in ranges of 10 to 10%. Now, deciles, they don't exist, all right? They don't exist as a formula in Excel. What you do have are percentiles, all right? What you do have are percentiles, and they work pretty much the exact same way as the quartiles in Excel. You have exclusive and inclusive. I like using inclusive percentiles because, well, I've grown up to understand them better. So again, the percentile, it's going to ask you about pretty much where do you want to be placed in, all right? Percentile, pretty much, you could ask it, what is the 25th percentile? What is the 37th percentile? What is the 82nd percentile? But we don't want those arbitrary measures. We want the 10th percentile, the 20th percentile, the 30th percentile, which would be the deciles. In order to make that work, I'd have to make it this way. 0.1, that would be the first decile. 0.2, that would be the second decile, and so on, and so on, and so on. So, let's slice this up by deciles. I'm going to grab my percentile inclusive, where my array is this distribution right here, and my position is going to be this one, all right? My position is going to be this one. All right, now I just have to drag this down. Notice how the 50th percentile matches up to my second quartile, all right? Matches up to my second quartile because my second quartile is pretty much 50%. All right, and notice how in order to be in the top 10% of Excel users, at least those who took that exam, you just have to get a grade above 64%. All right, guys, you just have to get a grade above 64%, which is a very low bar. It's a very low hurdle to jump over. All right, so that would be the what do you call it? The deciles. Now, finally, and this is something that I don't think anybody uses anymore, it's the 5-point summary. So the 5-point summary is made up of the minimum, first, second, and third quartiles, and the maximum, all right? So it's just an issue of getting up the minimum from the normal distribution, from the grade distribution. The maximum, I already know, it's 92%, but I'm going to calculate it anyway. And the quartiles, which we already have up here. First quartile, second quartile, third quartile. All right, guys? And that would be your 5-point summary. Now, what is that good for? I'm still not exactly sure. I barely ever use those in my life. Deciles, I think, are really, really useful, but 5-point summaries, whatever. I mean, if you can figure out a use for those, let me know. All right, guys. So that's pretty much it for basic statistics. We've already covered like one semester of statistics in like 30 minutes. So don't complain if I overcompressed or oversimplified some stuff. But this is pretty much everything you need to know to work with statistics in Excel. Now, later on, I'm going to put out, and I mean, that's been a pending project for like quite a while now. I'm going to put out a video on inferential statistics where we're going to talk about normal distributions and hypothesis testing and stuff like that, how it's done in Excel. But that is something else for later. For now, we're done, and I really hope you liked the video. If you did, make sure that you smash that subscribe button and you leave your comments and your likes, whatever, make sure that you share. All right, guys, thank you, and I'll see you next time.